Lil Homie Steve and I would like to introduce you to the basics of networking. I have a chest here with 100 copper and 100 iron in it, and I have a few power poles, and I am going to build a very simple network just to show you the basics of how circuits are constructed and how we use logic. So I'm going to use one of these green wires. It doesn't matter if you choose red or green, they're down there on the right hand side. You just select one and then you click on your chest, and just to show you that little circuit connection icon there, currently this chest is not connected to anything. Okay, that's just how chests are by default. But if I grab that green wire, click on the chest, and then click on that power pole, now we have a circuit. So you see how those signals are showing up when I hover over the power pole? So those signals are being broadcast now by this chest. And it's that circuit connection that allows that to happen. And note the circuit network number. Here it's 1025. Every circuit gets its own number. And that's how you can troubleshoot. And we can extend it actually indefinitely. You can make networks as long as you need to. So it can run across the length of a spaceship, across the length of your whole planet. And here I'm going to put down a decider and connect that to the network. So that's 1025. The output is not connected, but the input is connected to 1025. So I can see that they're connected, and I can see the input signals there. So I can now use that information to make decisions, because this is a decider combinator. So I would like maybe to get a light, and just to show you the basics of how this can work, I'll just put this light down here, and I will connect that light to the network with another green wire. So that's connected to the output of the decider combinator. Okay, and I'm going to set a condition here. And this condition is going to be evaluated for whether or not it is true. And if it's true, it's going to execute whatever I tell it to execute. So let's say my condition is going to be that my quantity of iron, which is currently 100, is greater than my quantity of copper, which is also currently 100. So right now this statement is false. Iron is not greater than copper. But when that statement is true, I want it to do something, and here what I want it to do is output. In this case, I think I'll just select a letter, like the letter I for iron. You can select whatever you want. And I'm going to select that 1 so that it's outputting a steady single value of I. I'm not interested in a count right now. I just want the letter I to be broadcast if that condition is true. And if that condition is true, I want that light to turn on. So I'm going to enable that light if I is equal to 1. So I'll set 1 as a constant. And yes. So that's my condition. Now it's not true at the moment, so the light is not on. So I need to take some of this copper out. And now the condition is true, so the light is on. Here's how you can make lights different colors. So again, it's the same little network, but I've added an arithmetic combinator, or an arithmetic combinator. I think I've been saying it wrong. Anyways, we're still connected to our same network, and we're going to the input of our decider, and we're still testing to see if iron is greater than copper, which at the moment it is. And I'm outputting R just like before, just a steady single value for R. But that value is now being fed into an arithmetic combinator, and I'm multiplying it by 255. Now, why 255? This is a little hard to explain quickly, but this basically has to do with the way RGB, red, green, blue values work. Actually, it's a web design concept. But all you need to know right now is that 255 is the max value for any given color, red, green, or blue. So I want to output the maximum red value that my light can handle, and that's going to be 255. And then in my light, there's my output. So in my light, I need to say, I want the red input to be equal to whatever the value of R is. I have to set this to always on, by the way, because the default value of lights is to be on in the daytime on at night and off in the daytime. But anyway, I set my red to receive R at 255. Here's what happens if you change that value in your arithmetic combinator to something else. It's a different shade of red. You see, now red is only 50. So that's how the RGB values work. Imagine it like a slider almost. You can just slide those values up and get different colors for different values. So that will lead us into some cool stuff in my next tutorial, by the way. So yeah, at the moment I'm getting R and applying it to red, but let's say that I would like to make my light a different color. So I'll set that red equal to some signal that we're not getting. And I changed I didn't show you this, but I changed my value back to 255. So now my green is 255. My red is going to be 0 because we're not getting a value for V. I just chose that at random, and we're not getting a value for blue. But now I'll change it to blue, and see, now we're getting max blue. So thank you for your attention to this matter.